Hello everyone, myself Brunda. I am studying at Sri Venkateshwara College of Engineering in 6M from the course Renewable Energy Power Plants. Let me discuss about the zero energy concepts. The contents are introduction, why zero energy, how to adopt zero energy concept, features, advantages, disadvantages, and finally conclusion. Introduction. Zero energy concepts refer to building designs and technologies aimed at minimizing energy consumption and achieving a balance between energy demand and renewable energy generation on site, resulting in a net zero energy consumption. These concepts are a response to the pressing need to mitigate climate change and reduce dependence on finite fossil fuels by transitioning towards sustainable energy practices. Why zero energy? Zero energy buildings, for instance, are designed to minimize energy usage through features like high level of insulation, efficient HVAC systems, energy efficient lighting, and appliances. Any energy they do require is offset by renewable energy sources like solar panels or wind turbines, resulting in a net zero energy consumption over the course of a year. The idea behind zero energy is to reduce the environmental impact of buildings and promote sustainability by minimizing reliance on fossil fuels and reducing greenhouse gas emissions associated with energy consumption. Additionally, zero energy building can potentially save money for their owners in the long run by reducing utility bills. How to adopt zero energy concept? Adapting the zero energy concept can be approached at different levels, whether it's for a single building, a community, or even on a larger scale. Here, a step-by-step guide to adopting the zero energy concept. The first, assessment and planning. Assess your current energy usage and identify areas where energy efficiency can be improved. Set clear goals for your zero energy project, including targets for energy reduction and renewable energy generation. Design and construction. Implement energy efficient design principles in your building or project, such as a proper insulation, efficient windows, and passive solar heating. Choose energy efficient appliances, HVAC systems, and lighting fixtures. Incorporate renewable energy systems like solar panels, wind turbines, or geothermal heat pumps into your design. Energy monitoring and management. Install energy monitoring system to track energy usage and identify opportunities for improvement. Implement energy management strategies to optimize energy usage, such as scheduling equipment operations during off-peak hours and using smart building technologies. Education and engagement. Educate occupants or stakeholders about the benefits of zero energy and how they can contribute to energy efficiency. Encourage behavior changes such as turning off lights when not in use or adjusting thermostat settings. Maintenance and upkeep. Regularly maintain your building system to ensure they are operating at peak efficiency. Monitor renewable energy system to ensure they are generating the expected amount of energy. Stay informed about new technologies and practices that can further improve energy efficiency and renewable energy generation. Integration with community and policy. Explore opportunities to collaborate with local communities, utilities, and policymakers to promote zero energy initiatives. Advocate for policies and incentives that support energy efficiency and renewable energy adoption, such as tax incentives or zoning regulations. Let me look over about the features. High levels of insulation. Zero energy building typically features superior insulation to minimize heat transfer through walls, roofs, and windows, reducing the need of heating and cooling. Energy efficient appliances and lighting. These buildings incorporate energy efficient appliances and lighting fixtures, including LED lighting and Energy Star rated appliances to minimize electricity consumption. Passive solar design. Passive solar design principles are often utilized to maximize natural daylighting and heat gain during colder months while minimizing heat gain during warmer months, reducing the need for artificial lighting and cooling. Renewable energy generation. Zero energy building integrate renewable energy system such as a solar photovoltaic panels, wind turbines, or geothermal system to generate on-site renewable energy. This offsets the energy consumed by the building. Water conservation. Water efficient fixtures and systems are integrated into zero energy building to minimize water usage and promote sustainable water management practices. Site selection and landscaping. Careful consideration is given to site selection and landscaping to maximize energy efficiency and minimize environmental impact. This may include orientation related to the sun, landscaping for shading and rainwater management. Let me look over about the advantages. Energy cost saving, elimination or significant reduction of energy bills due to on-site renewable energy generation. Environmental benefits, reduction of the greenhouse gas emissions and reliance on fossil fuel, contributing to mitigating climate change. Preservation of natural resources by reducing overall energy consumption. Improved indoor comfort, higher indoor air quality and thermal comfort due to energy efficient building design and systems. Resilience and independence, greater resilience to power outages and disruptions in energy supply, as zero energy buildings often incorporate energy storage solutions. Reduced dependence can on centralized energy grids, enhancing energy security. Enhanced property value, increased marketability and value of zero energy building due to lower operating cost and higher sustainability credentials. Regulatory compliance and incentives, compliance with increasingly tightened energy codes and regulations, access to financial incentives, tax credential and rebates offered by governments and utility for energy efficient and renewable energy projects. Let me look over about the disadvantages. Higher initial cost, the upfront cost of implementing zero energy features such as a renewable energy system and energy efficient technologies can be higher compared to conventional buildings. Complexity of design and construction, designing and constructing zero energy buildings often requires specialized knowledge and expertise, which may add complexity to the process. Site limitations, not all sites are suitable for zero energy building, especially if there are limitations on renewable energy resource availability or building orientation. Performance variability, the performance of renewable energy system can be variable depending on factors such as weather condition and seasonal changes, which may affect the ability to achieve the zero energy goals consistently. Maintenance and operational considerations, zero energy building may require additional maintenance and monitoring of energy systems to ensure optimal performance, which can entail ongoing cost and effort. Occupant behavior, the effectiveness of energy efficient design and the renewable energy systems can be influenced by occupant behavior such as energy usage habits and preferences. Technological limitations, the availability and maturity of current renewable energy technologies may pose limitations on achieving zero energy goals, especially in areas with limited access to resources or infrastructure. Regulatory and policy challenges, regulatory barriers or lack of supportive policies at the local, regional, or national level may hinder the widespread adoption of zero energy concepts. Conclusion, zero energy concept offers significant advantages such as the energy cost saving, environmental benefits, and improved indoor comfort. They contribute to resilience, innovation, and economic development while fostering community engagement and social cohesion. However, there are also potential disadvantages, including higher initial cost, complexity in design and construction, and variability in performance. Overcoming these challenges require careful planning, technological innovation, supportive policies, and public awareness. Despite the drawbacks, the long-term benefits of zero energy concept make them a valuable approach for creating sustainable, efficient, and resilient built environment. Embracing zero energy principle can lead to a more sustainable future for generations to come. Thank you.